Well, good evening, everybody. Hi, I'm Derrick Pitts, Chief Astronomer at the Franklin Institute Science Museum, your cool astronomer, with another version of our Night Skies at Home program. Night Skies at Home is our home version of the Franklin Institute's Night Skies at the Observatory program. That's a program we've been running at Franklin Institute for quite a number of years, in which we invite our visitors to come join us at the rooftop observatory, where we get a look at whatever astronomical targets are available using the telescopes we have in our observatory and on the fifth floor roof deck. Of course, we incorporate lots of other content and programming to make it a complete evening, and hopefully we'll get back to that soon. But in the meantime, while we're all at home, we're doing Night Skies at Home. Night Skies at Home is also one of a number of programs that you'll find on the Franklin Institute's webpage at our Franklin at Home section. This is a section where we provide all sorts of content for you to enjoy while you're at home under COVID quarantine. So lots of content available on the Franklin Institute's website, and of course, this program, Night Skies at Home. This program is to help you become an astronomy observer, almost an expert, if you will, at observing the night sky right in your neighborhood. The whole idea, of course, is that astronomy is something that we can all connect with. Everybody enjoys looking at the night sky. Everybody enjoys looking at the moon. Everyone enjoys looking at planets. And this program will help you get oriented to how you can learn, understand, become very familiar with the night sky, and then, most importantly, share that with others. You know, astronomy, astronomical observing, the kind that we're doing, is something that people can do no matter where they are. And it doesn't really take a tremendous amount of knowledge or even equipment to be able to enjoy the night sky. And it's something that you can do where you are. Other family members in other parts of the region or around the country can do where they are, and you can actually share the experience. And I think that's really one of the best parts about it, is sharing the experience with others. After all, I know for me, nothing gives me greater joy than to share with people what I'm seeing in the night sky. No matter where you are, we're all under the same moon, we're all under the same sky, we can all enjoy the night sky. There is a cosmic connection that humans have with the sky and the universe. After all, all of this came out of the universe as we see it, so we can reconnect with it and enjoy that cosmic connection. The other thing I'll mention about looking at the evening skies is, you know what? It's actually kind of a physical interaction of looking at objects in the night sky. So for example, our sun, the brightest object we can see in our sky day or night, is about 93 million miles away on average. And we're going to learn a little bit more about that this evening, because actually the sun is a little bit further away right now, although if you're in the Delaware Valley, it may not feel like it. It might feel like the sun's much closer. But it's actually a little bit further away than normal. Well, over that distance of 93 million miles, you know, it takes light from the sun 8 minutes to reach us. Almost 8 minutes. So when you see sunlight, like this evening, well, that light left the sun 8 minutes ago. So traveling at the speed of light, 186,282 miles per second, or 300,000 kilometers per hour, per second rather, that it still takes the light 8 minutes to get here. That's how far away the sun is. Now the moon is much, much, much closer than that. It only takes half a second for light to get from the moon to Earth, because it's not so far away at all. So that's much better. But here's the way in which it's interactive. Let's say you're observing a galaxy, a very distant one, like the Andromeda galaxy, for example. That galaxy is 2.9 million light years away. That means the light that we see tonight from that galaxy, that light left that galaxy almost 3 million years ago. Here's another way to say it. We see that galaxy tonight as it looked 3 million years ago. Well, when you see that galaxy, your eye is actually collecting photons of light energy from that galaxy, from the stars of that galaxy. Those photons interacting with your retina creates an electronic impulse that then goes to your brain. In fact, your retina is actually a piece of your brain. Well, those photons touching your retina came from those stars. So you're having a physical interaction with the stars of a galaxy 3 million light years away. Those photons become yours. So now you've had an interactive experience with astronomy. That's what I think is so much fun to share. with others, and for you to sort of like own a piece of astronomy yourself, because those photons come to you and not to anyone else. Those are your photons. Okay, so we have a lot to do this evening. First of all, we're taking your questions. Please send us your questions so I can answer them for you, or at least try to answer them for you, or direct you to some place where you can find an answer. Sure, be happy to do that. So we want to hear your questions this evening. Also, tonight, we're going to talk about robotic telescopes and robotic observatories. Now, last week we talked about telescopes, the basics really. What kind of telescopes are there? Reflecting telescopes, refracting telescopes, how they work, what you need to look for if you're planning to purchase a telescope. Tonight we're going to talk about robotic telescopes. And you'll find on the market these days, there are a number of telescopes out there on the market that are operated with a device like this. Now, this is an older version, but it's like a handheld remote control. And these give telescopes much greater capability to point to objects that you might want to try to see. So we'll talk about that. Then the robotic observatories are observatories that you can access online and directly operate telescopes in other parts of the world so that you can not only do observations from other locations on the planet, right from your living room, but you can also use those telescopes to capture images of those objects. And then those images belong to you. So we'll talk about that too. Also, coming up on Saturday night, did you know there's a lunar eclipse coming up Saturday night into Sunday morning? We'll talk a little bit about that. And also, remember I said something about the Earth being farther away from the sun right now? Well, guess what? Turns out that Saturday is a very special day in the celestial calendar of the Earth's motion around the sun. We'll talk about that too. So we'll get to that too. But we want more of your questions, like I said. So let's see if we have any questions to start with. We'll throw a few of those in, and then we'll jump off into talking about robotic telescopes, robotic observatories. Send us your questions. Hi, what do we have, Linda?
What planet is visible in the morning in the northeast?
Oh, what planet is visible in the morning in the northeast? All right, let's see. Let's be careful here, because if we're looking over toward the eastern side of the sky, if it's very, very bright, then the object you're actually seeing is Jupiter. Jupiter is the bright planet you're seeing. Oh, wait a minute. You said in the morning in the northeast. Huh. In the morning, pre-dawn sky in the northeast. You know what? If it's in the northeast, I'm going to say it's not a planet. It must be a very bright star. That's what I'm going to go with. And you know what we're going to do? Let's do this later. Let's jump into our Stellarium program a little bit later, and we'll dig up what that object might be in the northeast in the morning before sunrise. That's what I'm going to guess it is, okay? In the morning in the northeast before sunrise. And the reason why I say that is because, first of all, planets aren't found in the northeast portion of the sky, so maybe our direction is off a little bit. If we're talking about the southeast portion of the sky in the morning before sunrise, well, most of the planets, the bright planets, have now moved on from that portion of the sky, and the big bright planets of our solar system are really visible over in the southwestern portion of the sky at sunrise. So I'm going to guess it's a star. We'll figure out which one it is. Let's do another question.
How far away are we from the nearest black hole?
Whoa, how far away are we from the nearest black hole? Well, we are thousands of light years away. We are a really good distance away. We don't really have to worry about that very much. We talked about that in one of our programs a few weeks ago when we were talking about, the closest black holes, the biggest black holes, the first discovered black holes. So we're really several thousand light years away. We're pretty safe over here. We don't really have to be concerned about anything affecting us from the black hole. So we're in good shape. We'll see if we can dig that information up for you also during the course of the evening. So that's two assignments I have already. So we'll see if we can get to those. Okay, great. What's another question?
Can you talk about and explain the lunar eclipse?
Oh, yes. Can I talk about and explain the lunar eclipse? Sure. So here's what we're going to do. Let's talk a little bit about sky phenomena. We'll talk about the eclipse right now, too. Thanks for that question. That's a really good one. So guess what? Let's talk about the changing times of sunrise and sunset. We've already lost 4 minutes and 8 seconds since the summer solstice. That's 4 minutes and 8 seconds of daylight today from the summer solstice. So already we're losing time. Sunrise is now at 5:36 a.m. It used to be at 5:33. So there's 3 minutes of the time right there. And sunset still seems to be at 8:33 in the evening. So that's languishing a little bit. But in there, we have 4 minutes and 8 seconds we've already lost. So the moon is now in a waxing gibbous phase. It's about 12 and a half days old. And so by Sunday, it will be full, okay? So the full moon comes up next on Sunday, and that's why we're going to have this lunar eclipse that's going to happen, because the moon is coming to its full phase. Now, when the moon's at its full phase, here's what's happening. We have the Earth placed between the sun and the moon. Light from the sun illuminates the surface of the moon. And the moon's position, typically for full moon, is in a portion of space along its orbit where the moon actually is above the shadow of the Earth. Think about this for a second. Did you ever bother to think about the Earth's own shadow? Sure, any object that blocks light from a light source creates a shadow. You do that if you stand outside under the sun. You do that if you stand in front of a lamp inside your house. The sun, the Earth, blocks light from the sun and creates a shadow. That shadow trails out into space. Well, when the moon orbits around the Earth, typically it will travel above the shadow or below the shadow. If it travels into the shadow, that's when we have a lunar eclipse. Now, the lunar eclipse that's coming up on Saturday, you'll be able to see that overnight from Saturday night into Sunday morning. 12:31 a.m. is the peak of that. So you can get out and take a look at that. But this particular one is called a penumbral eclipse, a penumbral eclipse. Let me see if I can describe this for you so that you can understand it. The shadow that's created by the Earth, trailing out behind it, has two parts. It has an inner portion that's called the umbra, and it has an outer portion called the penumbra. Now, the inner portion is the darkest portion of the Earth's shadow. When the moon passes into the umbra of the Earth's shadow, we can see the moon under what's called total lunar eclipse. And that's when we can see plenty of color on the surface of the moon. It's as an umbral eclipse passing into the deepest portion of the Earth's shadow, that's when we can see most of the color. And that's what we look for when we want to see a lunar eclipse, is we love to see that color. It can be anywhere from tan to bronze to reddish brown, and very dramatic looking in color. And it's exciting to see this, because this is also a way that you can tell that the moon orbits the Earth, because you can watch the moon as it slides through the shadow of the Earth. So you can tell that too. Now, in the case of a penumbral eclipse, here's what happens. The moon slides through that lighter portion of the Earth's shadow. Now, if it doesn't go very deep into that lighter portion of the Earth's shadow, you can hardly even tell an eclipse is happening. So on Saturday night into Sunday morning, step outside, take a look at the full moon. 12:31 will be passing through that penumbral portion of the Earth's shadow. See if you can detect any color. It should be, if you could detect any color, it might be a light amber, very, very faint, very, very light amber. But I'm not going to gamble that you're going to see very much. In fact, among some of us in the astronomy community, we sometimes debate about whether it's worth mentioning about penumbral eclipses because the coloring is so slight. So if you go out to look and you don't see very much, it's not you. You're not out at the wrong time. It's not happening on a different day. It's just that there's hardly any color. Now, here's the other effect that happens on that evening that's really cool. Since it's nearly full moon, the moon will be rising almost as the sun sets. So on Saturday night and Sunday night, in the evening, just after sunset, you'll be able to see the moon rising over on the eastern horizon. If you have a clear view of the eastern horizon, guess what? You're going to see the moon looking really, really, really large. And you're going to wonder, hey, is this a supermoon date? Nope, it isn't. Whenever the moon is rising as a full moon or close to full moon, and you watch it as it rises on the eastern horizon, you often see it near objects on the Earth of known size. Well, this sets up an optical illusion, a trick of the eye, if you will, for our brains, in which we see the moon as looking really, really big. And we might think it's atmospheric refraction or some kind of magnifying effect or something like that. It's none of those things. It's the optical illusion. It's all in our heads. And in fact, you can test this because you can measure the size of the moon at the horizon, and then you can measure the size of the moon again as it's directly overhead. And you'll see that it's the same size. Convenient way to do that, you can take your thumb, hold it up like this, and measure the size of the moon like this at the horizon, and then measure it again overhead. You'll see it's the same size. It's just the optical illusion. Okay? So, don't worry about a supermoon date. Just look at the moon whenever it's full, rising on the eastern horizon, and you can do that every month. So you can duplicate the supermoon effect every month. See? Not too difficult, right? Okay, you can do that. All right, so that's about the lunar eclipse. There is another lunar eclipse coming up, let's see, later this year, November 30th. There's another lunar eclipse, but not visible to us. So don't worry about that. When the next one is available, I'll be sure to let you know. And of course, you can go online. There are so many sources available to give you information about when these astronomical phenomena are happening. So don't wait for me. You can go online and check it out yourself. In fact, if you're interested in eclipses and you want more information and really detailed information, but easy to understand, look up this guy, Mr. Eclipse. Mr. Eclipse, okay? His name is Fred Espenak. He's a former NASA engineer who's created this fabulous website that has information about eclipses for thousands of years backward into the past and forward into the future, with all sorts of diagrams and easy to understand information, so you can become an eclipse expert. Go check out Mr. Eclipse. You'll get all the details you know there. All right, great. What's up next? Well, as it turns out, also on Saturday, another very special thing is happening. Now, we all know it's July 4th, United States American Independence Day, but there's something else that happens, an astronomical phenomenon that really isn't connected to the Independence Day thing. It is this. It's called aphelion. Aphelion. A-P-H-E-L-I-O-N. Aphelion is a point in the Earth's orbit when the Earth is at its greatest distance from the Sun. Aph meaning distant, helion meaning sun. So aphelion is the Latin word for Earth at its greatest distance from the Sun. Now, you might be thinking to yourself, wait a minute, what is this guy talking about? It's summer. We're burning up. It's 93 degrees here in Philly. We must be closer to the Sun. No, that's not that at all. Even though the Earth is farther away, the axis of rotation, tilt of the Earth, is tilted toward the Sun. So that means we are getting our sunlight on the northern hemisphere in much more direct rays than we do at any other time of the year. That direct ray impinging on the surface of the Earth gains heat faster. That means we warm up here, the air then warms up, and that's what we feel. So for the southern hemisphere, we're now in winter, and that's because the bottom of the Earth is tilted away, so less direct rays, okay? So even though we're at a greater distance, the rays are more direct, and that gives us the heating here in the north, all right? So what's the real distance? The real distance is 94,507,450 million miles away. You got that? 94,507,450 million miles away. That's how far away we are on Saturday at 7:35 a.m. Now, here's the interesting thing. It's just an instant. It's just a moment in time. The Earth, in its motion around the Sun, is on a continuous trek. So as it's making its orbit around the Sun, we come to this point called aphelion. The Earth doesn't stop there. It continues on its way. So that aphelion point, when we're at that most distant point, that's really just an instant in time. And a minute later, we're already increasing the distance away from we're already closing the distance to the Sun again. So guess when we get to our closest point to the Sun? Ready for this? So if we're at the most distant point at this time of year, orbit around the Sun, well, let's come 6 months from now. Yeah, you're right. Guess what? Next year, it's going to be January 2nd, 2021. We'll be at our closest distance to the Sun, and that'll be 91,399,000 miles away. 91,399,000 miles away. January 2nd. For us in the Northern Hemisphere, it'll be the middle of winter. Whoops, all kinds of things happening here. Sorry about that. We'll be in the middle of winter, and so we'll be kind of on the cool side here. But again, it's not about how close we are to the Sun. It's about that tilt, that angular tilt that we have. That was my water bottle that went over there, folks. Thank you very much. Okay, great. So we're back together again here now. So that's what's happening there. Okay, now. So that'll take care of the lunar eclipse question. Hopefully that gives you the information you need for that. And now you're armed for astronomy information also for aphelion on July 4th. Not just Independence Day, but the point at which the Earth reaches its greatest distance from the sun. All right. Okay, so now, what's great for us to see this week? Well, there's still those fabulous planets that are making their way into the evening sky. It's Jupiter and Saturn. They now rise at 10 p.m. Mars rises at 1 o'clock in the morning. So you can see them through the night now without much difficulty. They're all well up in the west and the southwest by sunrise. But you don't have to wait that long. Anytime between 10 p.m. and, say, 1 a.m. or 2 a.m., you can actually go out and see the planets. If you're going to watch the Penumbral Lunar Eclipse on Saturday night, if you're out there at 12:30, you'll be able to catch those planets up, and another half hour later, Mars will rise on the eastern horizon. So if you're out until 2 still partying, I don't know about that, you'll at least be able to catch those planets and the moon in the evening as long as skies are clear, all right? Good, so that's really cool. Constellations we're going to talk about this evening are Sagittarius and Scorpius. We'll get to those in just a little bit. But let's do this first. Let's jump off into our talk about robotic observatories and robotic telescopes. And then we'll come back to, and we'll do the sky, and we'll answer those other questions we had earlier about what's that star that looks like a bright star in the northeastern portion of the sky in the pre-dawn hours. We'll check that out. We'll also do something about that distance to the nearest black hole. We'll cover that one too. All right, so let's do this. I'm going to put this down for the moment, and we're going to switch things around here. What we're going to do is I'm going to slide my computer a little bit forward so I can share the screen. So if you'll just bear with me here. We're coming forward. There we go. Okay, now that way I think we can reach this a little easier. There we go. Okay, how's that? Great. Okay, hopefully you can see my SpaceX rocket over my shoulder here, this really great model. Isn't that fabulous? Okay, great. All right, so folks, I'm going to share my screen here. Do we have another question we can try to answer at the moment before we jump out here?
Yes, we do. 8-year-old Rafaela wants to know, how strong is Jupiter's storm?
Ah, hi there, Raffaello. You're 8 years old. Thanks. Raffaella, thanks for joining us, Raffaella. You're 8 years old. You want to know how strong is Jupiter's storm? The storm that you're talking about is the great red spot that we see in the upper atmosphere of Jupiter. That is a truly intense storm. It's amazing. It's gigantic. Did you know that we can fit, hold on, I was going to say we can fit 4 planet Earths in the space of the storm. But the space, the size of the giant red spot has decreased a little bit over this last couple of decades. So I think it's only about 3 Earths, maybe 3.5 Earths we can fit inside it. But it's the most intense storm in the solar system, no question about it. Very, very high speed winds, hundreds of miles an hour. And that storm has been going on for as long as we've been observing it. And that's 400 years that we've been observing it, a little more than that. But we know that the storm was in existence long before that, Raffaella. So it's a really intense storm, the most intense storm in the solar system, without question. You know what? If we did line up 3.5 Earths in that storm, the Earth would be swallowed up and swept away. That's how intense it is. So here's what we're going to do, Raffaella. We're going to make sure that we don't get the Earth anywhere near that storm so we don't have to worry about it. Okay? All right, cool. Thanks for the question. All right, I'm going to share my screen now, folks, and I'm going to jump out here, and we're going to take a look at some robotic observatory information. So if you will, please just bear with me while I get everything together here. Right, here we are. We are at robotic observatories. Now, I'm going to, you know what I'm going to do? I'm going to do something a little bit avant-garde here. Just hold on with me for one moment. I'm going to do this. And the reason why is because I want to show you something very important. Now, it doesn't really matter which one I choose here. So I'm going to go to this right here. Here we are. You'll see I've got a bunch of ads up here for telescopes and things like that. And what I'm going to do is I'm going to go down here and I'm just going to see if I can select the one. Oh yeah, here we are. All right, I'm going to go to this website. This is the Celestron website. And the reason why I'm going to this website is not really because I want you to buy a telescope or anything, but I just want to show you a piece of equipment that's important for you to understand. And it is this. here we are at this particular website where we're looking at something called a computerized telescope. Yes, folks, nowadays what's happened is that the price of memory and the price of computer chips has dropped to such a degree that they're now being incorporated into telescopes so that we have what can be called a robotic telescope or a computerized telescope. So this is an example of a computerized telescope. Pay no attention to the price. That's just for this model. There are computerized telescopes that cost much less than this, so don't worry about that. But what I really want you to see is the hand controller here. That's what I'm really after more so than anything else, is the hand controller. And the reason why is because the hand controller, I can't seem to get a really good, yes. This hand controller that you see right here, this hand controller allows the operator now to actually not only run and use the telescope through the hand controller, but it gives you a tremendous number of functions that never were available for a telescope's operation. Here's what I mean. First of all, often these telescopes have a GPS sensor in them so that using GPS satellites, they know exactly where they are on the planet. They know exactly what date and what time it is. What that then allows the computer to do, the computer in the telescope to do, in conjunction with the memory chip that's on board the hand controller, is that now the telescope can map out for its little computer brain a map of the night sky for where you are at that date and time. So now the telescope has an idea of what's overhead. Because it has that idea of what's overhead, what it does is it now refers to a catalog, a star catalog of everything that would be available in the sky at that time and that location. All because memory and computer power has become so much smaller and so much cheaper. It can now be incorporated into a very small hand controller. Now, what does that do for you? Well, what that means is that you can now access all that information, and you can use the telescope's computing power, or the computer in the telescope. You can use that computer power or that computing capability to tell the motors in the telescope where to go to look for an object. Wow, doesn't that make a difference? Of course it does, because now what happens is you can actually use the hand controller, and I have an older model here. You can actually use the hand controller to tell the telescope where to go in the sky to look for an object. It's almost as if I'm saying, you don't have to know where the objects are because the computer controller does. Now that's pretty close, but that's not a 100% accurate. The reason why is because the telescope has no idea really where it points until you tell it what objects it's seeing. So here's what I mean. Even though the telescope knows where it is on the planet, knows what date and what time it is, until you tell it what object it sees first, it doesn't know where it's looking. So you have to have some knowledge of a few bright stars so that you can give the telescope a reference for exactly what it's seeing in the sky. Once you give it that reference, now it can use that information to find hundreds, thousands, hundreds of thousands of objects. Do you know that for these telescopes, there are well over, I think the number is something like 150,000 objects that the telescope can find using this computerized system. And it makes a huge difference because it now helps you to find all sorts of things that you might not have been able to see with your own eye. So this is really a tremendous step forward in telescope technology for use at home. Now it's relatively inexpensive and it can work really, really well, but it still needs you to give it some information to get started for where it wants to go. Once you get it set up in the evening, and it takes you maybe 5 minutes to get it set up, you're good for the entire night. And all you have to do is just select where you want to go and then press the go to button, and the telescope will automatically go to the object. So you don't have to hunt around for objects in the sky anymore. Planets, stars, galaxies, nebulae, any sort of object that the telescope believes is available above you right then, that's where you can get the telescope to point to. Now here's one thing that the telescope won't do for you. It won't give you dark skies. So even though you have such a sophisticated telescope, guess what? If you still have bright city lights around where you live, that's going to make it much more difficult to see the deeper objects, the more distant objects. So if you want a telescope like this, you want it to be portable enough that you can take it to a place where the sky is dark enough where you can take advantage of this capability. You can learn all about these telescopes online. You'll remember I gave you a website last week, telescope.com, the Orion Telescope Center, where you can find out all sorts of information about computerized and robotic telescopes. And that way, you can decide whether this is something for you or not. Robotic telescopes, computerized telescopes, a great step forward, but you still have to know a little bit about the night sky, okay? You can send questions about that too. I'll be happy to do that. Okay, let's jump out of here because now guess what? Now we're going to talk about robotic observatories. Robotic observatories. I don't know if you've ever heard of robotic observatories, but we're going to start with this one called slooh.com, S-L-O-O-H. Now, the Slooh website is a location. Slooh is an organization that has made available for the observing public a series of telescopes at observatories in 2 different locations around the world. One of those locations is down in South America in Chile at a place where the skies are really gorgeous. And the other place is at an island out in the Atlantic Ocean off the coast of Africa called Tenerife. So these are 2 fabulous locations where the sky is clear and dark. There are a number of telescopes mounted at these locations, and you can use those telescopes yourself, and Slooh is one of those portals that will take you there. So let's jump into this and see what's out there. So you can see I have the screen set up for you here. It's called Space for Everyone Slooh. You can access this through a membership, and I do have a membership. So here's what I'm going to do. I'm going to slide over a little bit. I'm going to sign in here. Don't steal my password. Let me get out of that so you can't see it. There we go. Now, I've jumped into my account right here. And it shows that I'm at the beginner level. I've been a member since 2008. Yeah, right. And I've used this at the observatory down at Franklin Institute on those nights when the sky hasn't been clear. I've accessed the telescopes through Slooh at places where the sky may be clear, so our visitors will be able to see something of the night sky. And that's what you can do with this. You can actually just jump in and go look at the observatories elsewhere around the world, okay? So that's what this website does, is it provides you access. Now let's go see what telescopes are out there, okay? So I'm gonna click on this icon right up here, and what this icon now shows me is this list of telescopes. So you can see the first 3 here, Chile 1, Chile 2, Chile 3, are all offline. Could be service that's happening for these telescopes right now, and that's the reason why they are offline. But let's go down here. Look, there's Canary 1, 2, 3, and 4. All of them are online. So let's go out and let's just look at Canary 1. We'll use this as one example of what you can do here on Slooh. So now what I've done is I've hit the Chile 1 button, or the Canary 1 button, and you can see here are the selections of telescopes that you can choose from up here across the top of the screen. And right here is the image that's being seen right here, right now, through that particular telescope. We'll find out which telescope it is in a moment. But let me just show you this. This is the view coming through the camera that's on the telescope. Now you're wondering, what is this? Well, if we look right over here on the right-hand side of the screen, we can see what's called the current mission. This mission is scheduled by a member called John S. And John S. is looking in this catalog, the ARP catalog of peculiar galaxies, for this particular galaxy, 328. He's looking for ARP 328, and he wants to get a photograph of it. Can you see it here? I can't. Don't worry about that. That's okay. That's John's mission. That's what he wants to do this evening, and he's using this particular time to do this. Now, John's only going to use this telescope for a short period of time, and that's because there are other people that want to use it. So if I go over here and select Q, what I find for the night of Thursday, July 2nd, is this, is that right over here, Gus H0.2019 has scheduled the telescope to look for these coordinates at this particular time. Now it says 0030 UTC. Well, that's Coordinated Universal Time, which is really 8:30 p.m. So at 8:30, he's going to get to use the telescope for 10 minutes. How do I know it's 10 minutes? This is where he's going to go, because if I go to who's next in the queue, I come to DB Astro TXST, and he's going to use the telescope at 8:40 p.m. He or she is going to use the telescope at 8:40 p.m., and they're going to go to these celestial coordinates. So now I can go down the queue, and I can see who's going to be looking at what when. All the way through the evening, I can find out who's going to be looking at what when. You could have your name there if you were to jump on board at SLU and do this. So we can check out the sky conditions at Canary 1, and we can see what the sky conditions are right here, a level 2 sky conditions. The dew point, humidity level 24 degrees Fahrenheit. There's the humidity 20%. It's 66 degrees. There's no wind, no gusts, and there's a lot of moonlight tonight. You can see the phase is 94%, almost full, and moonset doesn't come until 4:29 UTC, so that'll be a little bit after midnight. Let's go back up here. We're going to take a look at the scope right here, and this tells us, here's where we are. Oh, this is the information we need. And here's the telescope. It's the Canary 1 half-meter telescope. So we can find out all kinds of information about this, but guess what? This is how this works. You become a member, and then you get to use any of these telescopes. Now, let's just take a quick look. We're going to go from Canary 1 to Canary 2. Okay, and you'll notice this is now changing its field of view. We're going to go to the live view just to see what's there. Let's see how we're doing. Okay, now, if you look right down here, you can see what the view is supposed to be. It's Saturn. You recognize the shape, right? But it looks like it's a little out of, I don't know, color coordination. So obviously the person that's doing this, or how the telescope is working, is going to have to do some color correction to give us a good view of this. But don't worry about that, because that'll be taken care of. This is just one of the options that you have. Now, if you were a member here, you could take a photograph of that and put that in your own workspace here on SLU and keep that image as your own. That's Canary 2. Let's go to Canary 3 and see what the deep sky looks like. Okay, while it's getting set up, changing its field of view to match this particular telescope. This supposedly in the current mission is MEPEM, and looking for the Whirlpool Galaxy. Looking for the Whirlpool Galaxy. So it looks to me like there's some additional work that has to be done here. But you have access to the telescope. You could have access to the telescope, and you could be into the queue for the evening looking for whatever it is you want to look for. So you can see there's Canary 4 right here. We're at Canary 2. Let's go over to Canary 4. I'm sorry, Canary 3. We'll go to Canary 4. Let's go to the live view, see what's available. Supposedly the Saturn Nebula. Well, it depends what the sky is looking like, but here, there's a view of what's called the Saturn Nebula. This is a feature in space that resembles the planet Saturn. But hopefully this gives you some idea of how this particular robotic observatory works. SLU is a really good one to get involved in because they have a tremendous amount of resources available for you. So I'm going to back out a little bit here and see if I can come back to some of the resources that are available for you. Let's see if I can make this work. Oh yes, here we are. So I'm back to my mission page right here. And one of the things I'm looking for here is, oh, I forgot to mention. So here's a whole group of photos that people have taken over time. For example, there's one of Jupiter right there, right? You can get the details about this if you want to, but it just gives you an idea of how well the telescopes work. And of course, you can look through a number of these. There's even an education section to this that sets up a whole series of observations for you to make that will teach you about the night sky. And what you do is you go through step by step, collect images that people have taken of the different objects representing different astronomical concepts, and it will teach you about astronomy as you go through the sky. Okay, well that's SLOOH, SLOOH.com. You can become a member for as little as $20. You can become a professional level astronomer, if you will, for as much as $300. And there's even an option for astronomy clubs to join, in which members of the club all have access to the telescopes too. So there's a number of ways you can do this. That's the first one right there, SLU, okay? So let me see, I think I have another one here I'd like to show you. I'm gonna go to this one. This one is called itelescope.net. And here we are now at itelescope.net, where there are 18 online telescopes at 4 different observatories. Look at the number of imaging sessions they've provided, 376,000 of them. So you too could join up with something like this, get on board, learn how to use the telescope, and you can scroll down here to see, for example, some of the things that's going on here. Astrophotography, you can get into that, and you can use their telescope system to do astrophotography. They'll also teach you how to do astrophotography as well. So you can learn all about how to do this. So this is a great way to do that. It's a great way to learn about astrophotography and how it gets done. You go, this is Picture of the Day by itelescope.net members. Look at that. That's pretty cool. And if we jump back a little bit here, I'm going to go back to this page where we were before. Oh, yes, look at this. They do master classes coming up next year for looking for observing and photographing the night sky. But they also have one-on-one tutorials here. That's pretty cool, right? And of course, the news and updates page is down here. And of course, you can find out all about the telescopes. If you're back up here, you can take the option that will show you about all the telescopes they have. So right across the top here, you'll see if I go to this pull-down menu, there are telescopes in Australia, New Mexico, California, Spain, and Chile. So plenty of those. And there's a gallery, of course, of images that are available from those folks that have used itelescope.net to take images. So that's all pretty cool too. Now, I have one more that's kind of out there. Okay, so bear with me for a second. This one is called Worldwide Telescope. It's hosted by the American Astronomical Society, and this is a really interesting one because of what it does. Okay, so what I'm going to do is I'm going to jump out of this. And when you look at this, this looks really, really cluttered. It also works best on a PC. I'm working on a Mac, so we're not going to do too much demonstration with this. But here's what happens with this one. This one provides data sets and images from across the astronomy world that can be superimposed into this view of the night sky. So on the screen right here, this is actually a view of the night sky. But what we can do with this view of the night sky is we can go look at the astronomical objects that are out there. So what I did was I just zoomed in, and the database of astronomical objects is now populating the screen that we see here. And what you can do with this, of course, is you can now select from what are called collections all of the different things that you might want to see using this particular tool. Now that's really what this is. This is a tool that lets you compile the information that you want to see about the universe, taking data sets created by astronomers and astronomical researchers from around the world. There's all kinds of cool things. So I'm under the tab of Explore. So you could explore the Hubble studies, for example. That'll give you like a little tutorial about what kinds of studies Hubble Space Telescope has been involved in. We can do guided tours if you want. So for example, how about a guided tour of black holes? You can find that too. And then there are communities that you can join that are doing different kinds of observing. And you can just do some straight viewing by giving the information of where you are, what time you want to view, and all sorts of things like that. You can adjust the layers of what's available, which is what these data sets are called, by the way, layers. You can adjust these layers so that you can have this information available for you to see. And this is also a really, really cool thing to do. It's free, but it's complex, but you can jump into this and you can create your own content as well. For example, if you wanted to create your own guided tour, you could create your own guided tour if you like, and that would be added to the information that's available for anybody that wants to use it. Okay, so we've done 3 different robotic observatories. We did SLU, we did iTelescope, and this one called Worldwide Telescope. You can do that one too. I'll provide these links for you so that you can go find these if you want to dig into them. But they're pretty simple. SLU.com, itelescope.net, I believe it is, itelescope.net, and just look up Worldwide Telescope and you'll come across this one. That's easy to do. So there are 3 you can do. So If you don't have a telescope, if you don't want to purchase a telescope, if you're looking for a way to do astronomy from your armchair, these are 3 ways you can get in successively deeper and deeper and deeper to learn more about the night sky. Okay, so you can go from very, very simple to very, very sophisticated really, really quickly, right from the comfort of your own. All right, great. So we're going to jump out of these now because we now have to go back and we have to take a look at the evening sky of what's available right now. So you'll recall before we were talking about some things we might see. Here's the program that I like to use, Stellarium Web. You can see it right up here. I provided the link for that. If you just look up Stellarium Web, you can find it without too much difficulty. I have my time window open right down here in the lower right corner. It's for tomorrow morning at 3 a.m. And here's what we're going to do. Since we're right here, right now, let's answer that question. What's the bright object that we see in the northeastern portion of the sky in the morning before sunrise? Let's go one more hour further towards sunrise. Hey, guess what? Boy, you're way ahead of me, aren't you? Yeah, I'll give you a little bit of information. You take off and run with it. I love it. Well, here we are. We're at 4 o'clock in the morning. We're looking over toward the east. What's that really bright object? It's Venus. Now, I didn't mention it because I didn't realize that Venus was making its way above the eastern horizon at 3 o'clock in the morning this soon. I thought that was going to be a little bit later in the summer season. I guess I have to catch up and pay attention too. But that's what it is. If you're out there in the morning sky, 4 a.m., let's see how far we can press this. Even 5 a.m., you know what? I don't have my atmosphere on, so let me see how the sky looks. Oh, there we go. So I just gave us the real appearance of the sky at 5 a.m. You can see that object, that's Venus. So thanks for pointing this out. The reason why, I'm going to back the time up just a little bit here. The reason why I'm really appreciative that you pointed this out is because guess what, folks? If you're up in the morning before sunrise, if you have to be out at 4:30 in the morning, or even a little bit later, guess what? You get to see 4 of the brightest planets of the solar system, the 4 brightest planets of the solar system: Jupiter, Saturn, Mars, and Venus. So check it out, folks. Look at that. If you want to catch 4 bright planets, 4:30 in the morning, there's a little bit of reward for being out early for you, okay? Thanks a lot for that question. That led us to a lot of really cool information. Now let's just check this out really quickly while we're here. There's a satellite that seems to be coming across the sky at that time of the morning. It's a Starling satellite. Aha! This is one of those artificial satellites that's been put up by SpaceX in an effort to provide low-cost worldwide access to the World Wide Web through these satellites. So that's one of them. It's 1.71 magnitude, almost second magnitude, so it could be visible. And there's a string of them that are coming along. So there's another one right behind it right here. And sometimes you can see these, sometimes you can't. Depends what your sky conditions are like, but they're out there. So there's that, and that's the early morning of the sky. Now let's switch ourselves over to the late evening sky. And here's what I'm going to do. Since this is tomorrow morning, I'm going to back us up into tonight. So here we are at 9 p.m. And let's just get rid of the timing here. We're at 9:30 p.m. tonight. Hopefully you're following along with me without too much difficulty here as I shift things around. But there we can see we're looking south now. Over to your right, you'll find the letter W for west. And then over here is east. So the moon is up, of course, right now. At 9:30, the moon will be up. Then Jupiter will be making its way above the horizon. And then by 10 p.m., let's just run this forward. You'll see everything coming up there. And now we're right there at 10 p.m. We'll get rid of this. I'm going to take the atmosphere away just to darken it. Now you can see where we are here. We've got the moon, we've got Jupiter, we have Saturn coming up right behind it. Here's Saturn right here. But here's the cool thing, and it leads right into the constellations that are visible for us to take a look at this evening. 2 constellations of the summer sky I really like, and I encourage you to get out and learn these constellations. And the 2 constellations are Sagittarius and Scorpius. Now, I really like these constellations because they are easy to recognize. Bright stars with distinctive shapes that you can easily pick out of the sky. And in this case, they have planets nearby and bright stars as well. So let's jump into this because it's so cool. So, first of all, here's what we have. Right here along the sky is the Milky Way. This is the arms of our galaxy that we're looking right into at this point. as we look out in this direction toward the south at 10 o'clock at night. Hopefully your sky is dark enough that you can see the Milky Way out there. This is actually the richest portion of the Milky Way because guess what, folks? Looking in this direction, we're actually looking toward the center of our galaxy. We're looking toward the center of our galaxy when we look in this direction. So if you build a spaceship in your backyard, you'd like to get out to the center of the galaxy where everything is really happening. I think that's where we'll find the headquarters of the United Federation of Planets as well. So if you want to go visit the headquarters of the United Federation of Planets, jump in your spacecraft, head toward the center of the solar system. That'll be out here in this direction among the stars of the constellation Scorpius. I'm sorry, constellation Sagittarius. Scorpius is right nearby, but over here on this side. So here's what I'm going to do. First, I'm going to describe the general location of where the two constellations are. Then I'll bring up the lines and the artwork so you can see them. Okay? So let's start over here with Scorpius, one of my favorite. I'm going to start with the head of the Scorpion using these three bright stars. 1, 2, 3 right here make up the head of the Scorpion. And the Scorpion actually is looking out in this direction. Scorpion has 2 claws, one that comes down here, another that comes up right around here. There's the head of the Scorpion. And here's the heart of the Scorpion at a star called Antares. Antares. This is actually another Latin word, Antares, meaning anti-Mars. Ant meaning anti or not, and Ares being the Greek actually for Mars. Anti-Mars. And the reason why is because Antares is a beautiful red star. Looks really, really good. And if Mars were there in that portion of the sky, you might confuse the two. So that's what's going on right there. Antares. You can find it easily. Now we're on this side, the western side of the Milky Way. And here's how the body of the Scorpion goes. Here's the head. Let's take the center star. We'll come down through the heart of the Scorpion, Antares. Now we'll sneak down along the snaking body. We'll swing around the bottom of the tail, and we'll come right around to what's called the stinger right here. These two stars, named Shaula, represent the stinger of the Scorpion. So here's the head of the Scorpion, the claws of the Scorpion here, the heart. We come down along the snaking body and right back up to the tail and the stinger called Shaula. These are really, really easy to see stars. So you can catch this S shape in the sky that represents Scorpius the Scorpion. Now, if you go out tonight, guess what? Here's the moon right here. So you'll find Antares is not far from the moon, and that way you can easily find Scorpius as well. Now, what's the other one that I mentioned? Well, Sagittarius. Sagittarius is on the eastern side of the Milky Way right over here. And it's this group of stars we see down low. Now, I really like this one too because, again, it's bright stars. But it's in the shape of a teapot. A teapot. You ready? Let's do the teapot shape. So let's start here with the top of the pot. 1, 2, 3 stars mark the top. Good so far. Let's do the spout. 1, 2, 3 stars mark the spout. 4 stars mark the body. 1, 2, 3, and 4 stars right there mark the body. Caus Australis is this lower star that's right here on the body of the pot. And then the handle's right here. 1, 2, 3, 4 stars handle. 1, 2, 3, 4 stars body. 1, 2, 3 stars spout. 1, 2, 3 stars top. There you go. Teapot shape in the sky. Now, Sagittarius. Well, Sagittarius isn't really a teapot. Sagittarius is an archer, but it's a weird archer. Ready for this? It's a centaur, okay? A centaur. A centaur with a bow and arrow. I don't get that from this shape right here, do you? But that's what it should look like, and we're going to take a look right now. Let's just bring up the constellation shapes. There we are. Now you can see the shape of the Scorpion right here. Heart of the Scorpion, the head of the Scorpion right out here, right? Coming down around here. And then here's the teapot shape right over here at Sagittarius, okay? Again, bright stars, easy to recognize, no problem whatsoever. Let's do the artwork now. We'll add that in. And there you can faintly see the artwork. Here's the Scorpion right here. And here's the archer. Here it is, a half man, half horse, right? with a bow and arrow, arm outstretched, pulling the bow back, ready to fire it in this direction. Pretty interesting, huh? Yeah, there's some great stories that go with these constellation shapes that we see in the sky. One last thing I'll mention about the Scorpion right here is that actually, there used to be just 11 zodiac constellations. We needed 12 zodiac constellations actually to make everything work out so that there was one zodiac constellation per month of the year. So there used to be only 11. How was the 12th one made? Well, the 12th one was made like this. The claws of the Scorpion, right here, used to extend out in this direction. One claw this way, one claw this way. But Libra's out here right now. This star right up here, Zuben esh-Shamali. See that? It's an Arabic word, Zuben esh-Shamali. Let's go down to this one, Zuben el-Ganubi. It says right here, let's see, Sigma Librae, but Zuben el-Ganubi is really the southern claw down here. Now, Zuben esh-Shamali and Zuben el-Ganubi down here represent, let's see, that's Pi Hydrae, or a little bit far out. Yep, this one right here, this one right here. Yep, that one right there. That's the one right there. This actually means northern claw. Let me just check and see. Ah, there it is. Here's the northern claw. Here's the southern claw. Oh, hold on. Let me just check and see. Ah, yes. Here's the southern claw right here, and here's the northern claw right here. Okay. So we have the northern claw and the southern claw. So the claws used to extend all the way out there, but what happened was map makers pulled the claws back so that they could incorporate those stars into the constellation we now call Libra. And that's how we got the extra constellation. Now here's the other thing that shows you that this is what actually happened. Of all of the 12 zodiac objects, the word zodiac itself means circle of living things. Well, guess what? Libra is the only object that's part of the 12 in the zodiac group that's not a living thing. So this was added later to make up the 12th constellation, one for every month. All right, so we've seen a lot here in the evening sky, folks. Plenty of things in the evening sky. So now you know where to look in the evening sky. We're going to let this guy take a break for right now. We're going to stop the Zoom share here and come back to you right here. We've seen a tremendous amount. I know you have more questions, so let's take some more of your questions. We have a few minutes left. We can do that.
If we see light from billions of light years away, can life forms on planets see dinosaurs now?
Whoa. Let me see if I can get this together. If we can see light coming from stars millions or billions of light years away, can life forms out there see dinosaurs back here on our planet from where they are?
Millions of years ago.
Oh, that's a really great question. So let's say there's a star with planets, say maybe 80 million light years away. So the light that they're seeing from Earth now, 80 million years ago, would show them a time on Earth when there would have been dinosaurs roaming the Earth. That's a really cool concept. Thanks for that. I really like that. I don't think I thought about that, but that's really cool. Yeah. The only problem is, are their telescopes powerful enough? They can see our stars, sure, but theoretically, if they had telescopes powerful enough, they could see what our planet looked like 80 million years ago. Yeah, very, very cool. That's if they're out there. So there's another question. But the concept is a good one. I love it. Thanks for asking that question. What's next?
Can you recommend a sky viewing iPhone app?
Let's see. Can I recommend a sky viewing iPhone, smartphone app? Sure, I can recommend a sky viewing smartphone app. Let me take a look and see what I have here. You know, one of my favorites actually is, just a minute, I'll tell you. Oh yeah, Sky Safari Plus. I like Sky Safari Plus because not only does it give you a great view of the sky, but it also allows you to find and follow satellites. So I think that's really valuable and useful, the satellite piece. So that's pretty cool. But there are plenty of them. There's something called Luminos that's available. Let me see. Go Skywatch is another one that's free. Pocket Universe is another one. Sky Star Chart. Oh, I almost forgot my favorite of all, Stellarium. Stellarium is great for your smartphone. And the cool thing about Stellarium is it's free. So between Stellarium and Sky Safari Plus, I have enough information to be able to find my way around the sky no matter where I am. Sky Safari Plus has a fee attached to it. Stellarium is free. So there you go. Take your pick, whichever one you like. What's next?
Are there scientists who specialize in watching every planet?
Are there scientists who specialize in watching every planet? Sure, there are planetary scientists, there are planetary geologists. There are people who specialize in just the atmospheres of planets. So yes, there are. And, you know, if you were interested in a career in becoming a scientist that studies some aspect about planets, some obscure aspect about planets, guess what? There's a position out there for you. So don't think because you have some obscure interest in planets around the rest of the solar system, there's no place for you. Guess what there is? So sure, of course, there are people who study just planets. What's next?
How fast is Earth moving around the sun?
Oh, how fast is Earth moving around the sun? So folks, I'll tell you, this is one of those numbers that I don't keep on the top of my head because of the fact that I can easily find it online without too much difficulty. So here's what I'm going to do. I'm going to jump on this really, really quickly and see if I can find for you just how fast. Oh, how fast is the Earth? I got the answer for you right here. How fast does the Earth orbit the sun? Once a year. Once every 365 days. Yeah, I know, that's the smart aleck answer. But, you know, you can easily look that information up online because that's information that's easily accessible. I used to carry all that kind of detailed information in my head, but I don't anymore because it's so easy to find. So, tell you what, why don't you go jump out and look for it? You'll find it without too much difficulty at all. Let's see, the Earth's orbital speed actually averages 107,208 kilometers per hour or 66,616 miles per hour. There you go. There's the average speed, about 66,000 miles per hour. That's the Earth's orbital speed around the sun. Okay, great. What's the other question we might have?
People are asking about when they should start viewing the eclipse. What time does it start?
Just a second. What time does the eclipse start? Well, okay, so let's answer one other question before we get to that one. What's the closest? I'm looking up that question of what's the closest black hole? What's the nearest black hole to Earth? I'm going to see if I can find that answer, the nearest black hole to Earth. Let's see. It looks like the closest black hole to Earth is 1,120 light years away, give or take 70 light years. So there's that question about the black hole. What's the closest one? It's 1,100 light years away from us. No need to worry about that. And last but not least, we're going to go check out Mr. Eclipse, and we're going to have Mr. Eclipse tell us what we need to know about the penumbral lunar eclipse of June 5th. So, what's a good time to be out observing? Well, let's see. Okay, it looks like the greatest eclipse is going to be at 12:31 a.m. That's going to be the greatest eclipse. So if you go outside, just a moment. Yes. If you go outside to begin your observing, you can go outside at about, let's see, 11 o'clock. 8 minutes after 11 is when the eclipse starts. 8 minutes after 11. We get to the greatest portion of the eclipse at 12:31, and then the eclipse is over at, it looks like almost 3 a.m. Almost 3 a.m. So it starts around 11, ends at 3 a.m., and the greatest eclipse is at 12:31 in the morning. Okay? So there's your parameters for that. Although, I got to tell you again, don't expect to see very much. But if you do see some slight change, I'd be interested to know what you see. But you really shouldn't be able to see very much at all because of the nature of the eclipse. So That's pretty much it. Okay, don't forget that this might be a good time for you to get out and see if you can identify some International Space Station flyovers. And you'll recall we gave you a few websites for that you can use to do that. Of course, one of my favorites that I like to use for that is one called See a Satellite Tonight. You can see a satellite tonight, and perhaps International Space Station might have some flyovers coming up soon that you can check out under the evening sky. So you can try that one. As I said before, Sky Safari Plus will also give you some of that information as well. And of course, you can always go to NASA's website, nasa.gov, where you can go to their web tab called See Space Station. And that will give you information about when International Space Station is available. So how about another question?
What is the Milky Way made of, and have any stars ever disappeared?
What's the Milky Way made of, and have any stars ever disappeared? Well, the Milky Way is really all of the stars that are in our galaxy, somewhere between 300 and 400 billion stars. That's the number of stars we estimate in our Milky Way galaxy. The light that we see in the evening sky of the Milky Way is the combined light of those billions of stars. So here we are sitting out near the edge of the Milky Way, not at the edge, but out near the edge of the Milky Way. And as we look toward the constellation Sagittarius, we're seeing the combined light of those billions of stars. Have any of them disappeared? Sure they have. Why? Because stars are born and die all the time. So every once in a while, we may see one of these stars die out in what we call a supernova explosion. It's kind of rare to see that, but we know it's happening throughout the galaxy, so stars are disappearing. It'd be great if we could keep track of every one of them, but many of them are so far away and hidden by the dust and gas in our galaxy that blocks our view, we may not be able to see all of them. But we're learning how to see more and more all the time with the instruments that we developed to look at the night sky. So hopefully we'll have more information. One more question? That's it for the questions, folks. I want to thank you very much for joining us tonight. It's been a real pleasure having you on board, and hopefully you've learned enough information to help you get out and learn about the night sky. Remember, it doesn't take much for you to do this. All you have to do is go out a few minutes every night, and that way you'll be able to keep up to speed on what constellations are available, what planets are available. Don't forget, Jupiter and Saturn rising at 10 p.m. And in the morning sky at 4:30, you can see 4 planets: Venus, Mars, Saturn, and Jupiter. Thank you very much for that tip about Venus. And you can be the astronomer of your neighborhood with this information. Don't forget to share what you've learned about this. Thanks a lot for your great questions. We greatly appreciate it. And guess what? As it turns out, this is the last one of these programs that we'll be doing on a weekly basis, folks. We're now going to move to doing these programs once a month. Our next program is coming up on August the 6th. August the 6th. We'll give you all the information you need to ride out the rest of the month of August, and then we'll be back on a monthly basis beginning on August the 6th. And the reason why is because, guess what? The Franklin Institute is reopening. Next Wednesday, July 8th, the Franklin Institute will be open and welcoming you to come join us down at the Parkway. So we're looking for you to come join us at the Franklin Institute beginning next Wednesday. We're excited to offer a modified museum experience that's designed to celebrate science in a safe and welcoming environment. Along with the exciting programming that we typically have at Franklin, you'll also enjoy our limited engagement special exhibit, The Presidents from Madame Tussauds. Can you imagine a collection of all of the presidents ever in the United States as wax figures from Madame Tussauds Wax Museum? That's what we have at the Franklin Institute now, beginning next Wednesday, July 8th. And that exhibit will be available through January, but we encourage you to come now and check it out since we're opening next Wednesday. Advanced tickets are available for everybody. You have to have advanced tickets to get in, including members. So that's required, advanced tickets, but there's no online fees for those advanced tickets. Masks are required. Don't forget that. Masks are required. And we have enhanced cleaning protocols that we're doing all throughout the day to make sure the place is as clean as it can possibly be. So visit our website at fi.edu to learn more and reserve your tickets. So don't forget, next Wednesday, 10 a.m., Franklin Institute is open. We're welcoming you back. Come check out the special exhibit, The Presidents by Madame Tussauds, and enjoy all the other great stuff we have at the Franklin Institute as well. I want to thank you very much for joining me for these programs that we've been doing here since late March, helping you understand the night skies. It's been great having you aboard. Your questions have been marvelous. I look forward to seeing you next week. I'm going to be down at the Franklin Institute next week. I look forward to seeing you here next month, and of course for this evening program. And if you have questions, you can always reach out to me. I'm dpitts at dpitts@fi.edu, dpitts@fi.edu. And of course, you can follow me on Twitter. @CoolAstronomer is my handle. You can send me questions there and keep up with me for weekly updates of what's happening in the evening sky. Now, don't forget, stay safe. Most importantly, wear a mask. Did I say wear a mask? I meant to say wear a mask. And don't forget also, wash your hands. Wear a mask, wash your hands, stay safe. Thanks for joining us here, folks. Looking forward to seeing you down at the Franklin Institute starting next Wednesday. And we'll be back here for another episode of Night Skies at Home on August the 6th. We'll see you then. Thanks for being with us.